Hello everyone. Thank you for the introduction. I would like to start with a short presentation of my background. As already explained, I come from the Joseph Stefan Institute, which is the biggest or the largest research institute in Slovenia. It covers the areas such as physics, chemistry, biology, biotechnology, reactor physics, energy, and environment. It employs over 1,000 people, among which half of them are PhD holders. So I personally come from the Department of Automatics, Biocybernetics, and Robotics, but our group actually works in the area of human physiology and ergonomics, with particular emphasis on extreme environments. So a couple of years ago, our group was involved in a European project called the Heat Shield, which was a Horizon 2020 project. This project focused on or aimed to investigate the effects of heat waves on 5 European key industries, including agriculture, construction, manufacturing, tourism, and transportation. It also aimed to find different mitigation strategies which could improve the well-being of people which work in the sectors. But our role in this project was mostly focused on the manufacturing industry, and for this purpose, we collaborated with Slovene company called Odilo, which produces automobile rear lights. So just briefly about this company, the company operates 24/7, all days a week, which means that the workers are exposed to quite high temperatures. Also, because their work involves injection molding, you can expect that the temperatures are even higher due to that. If we look at the picture, we can see that the halls are big with high ceilings, which means that air conditioning is, of course, not feasible. When we had interviews with employees, we observed that they're well adapted to the heat. But on the other hand, they're not adapted to heat waves because during that period, they cannot recover when they come home. So they're exposed to heat at work and also when they go home. During this period, we actually installed the sensors within the company and also outside the company on the company ground, which was in collaboration with biotechnical faculty. In the table, you can see that there were 4 documented heat waves during that summer. And if we look at the indoor temperature and then the outdoor temperature, we can see that the indoor temperature fluctuated to a much lesser extent than the outdoor temperature. So it doesn't really vary that much throughout the time, but it also doesn't vary that much throughout the day. So the temperatures are quite constant. It's hot all the time. When we correlated the temperature with the productivity, which is documented in a company, we actually observed that the productivity dropped after the heat waves were already completed, which indicated that heat waves have cumulative effect. And this is actually a very important part. Unfortunately, you can imagine that looking at different physiological responses during the working process can be difficult. And that's why we didn't manage to record any physiological data when working with this company. But of course, it is a really important aspect which we are researching. And then we also looked at different studies that are available. And we didn't find any of the studies that would actually indicate how heat waves or longer periods of heat affect people. And for this reason, we decided to conduct a study which would simulate a heat wave. So for this purpose, we recruited 7 male participants to be involved in the study. And we conducted a 10-day confinement experiment, and this was in Olympic Sports Center in Planica. So on day 1, which we actually mark as day 0, it was familiarization with everything, with the experimental protocol. Then we had a 3-day pre-heat wave period, followed by a 3-day heat wave. and then a 3-day post-heatwave period. During the pre and post-heatwave period, the participants were exposed to 25 degrees Celsius when working, and when they were resting, they were exposed to about 22 degrees Celsius. But then during the heat wave, which is indicated by a red color, as you can see, they were exposed to 35 degrees Celsius during work and to about 26 degrees Celsius during rest and when they were sleeping. So every day they had quite a well-structured schedule. They woke up, had breakfast, and then they had to work. So they conducted simulated work, which actually included 2 different tasks. One was simulated assembly line task, during which they had to check the circuit boards. They had to check how is it called? The resistance of the circuit boards, and they had to evaluate whether it was appropriate, whether it was working properly, or it had to be discarded. So they had to make a decision whether it's good or bad. And then, on the other hand, they also did a step test to increase heat production of the body. So the stepping test you can see on the left, it's just basically stepping on an obstacle up and down. So if we look at the results, the heat waves are indicated by red bars. And clearly, we can immediately see that all the measured physiological data was increased when during the heat wave. So we can see an increase in core temperature. Of course, also the skin temperature was higher. The heart rate was increased. If we look at the thermal comfort and thermal sensation, we can see that participants felt less thermally comfortable and they were hotter during the heat wave, which is expected. And this was actually observed during the stepping test and also when completing a simulated assembly line task. And then if we look on the bottom right, we can see the number of mistakes they committed during the assembly line task. And we can see particularly that on day 1 of the heat wave, they committed more mistakes. But then the number of mistakes gradually decreased. So what can we conclude? We can conclude that the simulated heat wave increased the number of mistakes that participants committed, that physiological strain was also increased because we observed higher core temperature, skin temperature, and heart rate. And what we also observed and was interesting was the coping mechanism. The participants spent more time on unplanned breaks. So to kind of sum up, I can say that although the participants followed the guidelines for work under heat stress, we still observed a significant labor loss. But on the other hand, an important factor was also early adaptation, because on day 1, we saw a drop an increase in the number of mistakes they committed, but on day 2, the number was already reduced. So the adaptation has a very important part in dealing with heat stress. This was a novel methodological approach that we used, and of course, there is still a lot of room for improvement. Especially, we would need to recruit people that are, let's say, more susceptible to heat, more vulnerable groups, such as elderly. But this is something we plan to do in the future. So with this, I would conclude, and thank you for your attention.